Okay, in your slides for lesson 11, I'm just going to very quickly talk about these. So these functions are the description of your functions, and then these are the 4 graphs down below that match your function. So this is very quickly D, A, C, and B. So pointing out some key factors of A. So this is when you have 30 seconds, or the child has 30 seconds on a swing, and then the time runs out, and then the child has 0 seconds on the swing. I'm not going to talk too much about B, because this is called a piecewise function. We're going to be talking about that in the next lesson. And then C would be talking about or representing the distance that the swing is away from the top beam of the swing. So we don't want to get any closer, don't get any further away. It's not like the swing is stretching or anything like that. So we are at a constant rate. And then this is representing a child being pushed. So eventually as the child gets pushed, just keep getting higher and higher and higher, and then the time is running out, so then the child is getting closer and closer to being at the same height that he or she started off with. So this is one I really want to focus on, and that is back to the bouncing ball. So you have this graph representing a tennis ball being dropped from a certain height. So h of 0, so it says find h of 0. So you're trying to figure out what is the output when the input equals 0. So if my input is 0, then that means I'm at the order pair of 0, 6. So I can say h of 0 equals 6. So in regards to the situation, it tells us that the ball was dropped from a height of 6 feet. And you could say when t equals 0 if you'd like. Okay, so at the very beginning, the ball was dropped from a height of 6 feet. So h of 6 equals 0. So what we're looking for is all of our outputs. All of our outputs are 0. So that's when we're looking this direction. So we have, for example, 0.54, 1.48, 2.25. Looks here like there's a 3 or maybe like a 3.1 if you want to say. I'm going to say 3. It's closer to 3. Then we have one that seems like a little bit past this, so that's like 3.75, so maybe 3.8. Okay, again, these are just definitely guesstimates. So what this is actually meaning, this is each time the ball hits the ground. Okay. So if we're describing the domain of the function, domain is following how wide does your graph go. So our graph goes from here all the way to about here. So what kind of values are we talking about there? So we could say that the domain is all values between 0 and just less than 4 seconds. The range of a function is how low our graph goes and how high our graph goes. And you also have to think about if it was students or something like that where you could not have fractional values. So our range in this case, because we're talking about height, can be all values between 0 and 6 feet. So if we look at some of these, so if we're thinking about the domain and range, we're looking at, again, how wide is it? For the domain, here's our input. So we've already talked about how it's from 5 to 16, dealing with the students. You have seen this graph before, 5 to 16, but it can't be fractional. So we have to describe that. And then how low is it? And how high does it go? So this is representing the domain. This is representing the range. So if we looked at our drone, this is how wide it goes. And this is how low to high it goes. So what would that look like? I'm going to grab a different color. So we could do the same thing for the rocket. So now the rocket is this wide. So that is the domain. And then it goes from this high and this low. So again, that would be representing the range. We'll talk more about this. Again, it's a piecewise function. We'll talk more about that. We look at this last one. It goes from how wide. So right now it looks like it maybe stops here. Don't know. Oh, this is the dog one, I think. So yes, it does stop after 160 seconds. And so this is going to be how low is it? So the closest it ever got to the post was like 1.5 feet. And then the farthest it got away was the 5 feet, because that was as long as the leash was. So again, we'll talk more about this for domain and range.